Before the video starts, please, if you haven't already and if you're interested, go check out my website, HVACRvideos.com. I've got merch available on there. It helps to support the channel. So hats, shirts, beanies, sweaters, all that good stuff. A couple different designs on the shirts. So one of the things about these hats that I wanted to point out is that I purposely designed them to not have my logo on them. I just wanted them to say HVACR, so that way, you know, you could wear them and not conflict with anything going on at your normal business. I was hoping that companies wouldn't have an issue with a hat just saying HVACR because it's not necessarily repping my brand. It doesn't have my logo or anything like that, and I purposely did that. The other cool thing about these hats is I made them black underbill, okay? So that way our fingers don't wear them out. And they are a flex fit and they're a breathable material. It's kind of hard to see, but I can see through this material. It's not a trucker hat. It's not a mesh hat, but it's a breathable material. Super comfortable. Love wearing my hat. I've worn, I get about, I'd say 8 months to a year out of each hat. And that's with washing them, you know, in and out of the washer and everything. So I tried to make them, you know, as quality as possible, you know, with the available materials. So, all right, let's get on with the video. This video is brought to you by Sporlan, quality, integrity, and tradition. Today we have a call on a prep table that's not working properly. I think they currently have it unplugged at this time. So looks like there's some dinner right there. But yeah, I'm gonna jump into this and see what we can find. It's just a basic Delphil prep table, so nothing crazy. I open up the condensing unit section and we got a nice dirty condenser, but again, don't know that that's anything. The unit obviously isn't plugged in right now, so we know we're gonna have to clean that up. So I gotta start by finding out where the plug is and seeing if I can get this thing started up. Got the unit started up now. I plugged it in. Everything's a little wet, but you can see it about as clean as it's gonna get. Evaporator fan motors are running. It's a nice moldy avocado right there. Grab that guy. Dinner. Throw that away. All right, so that's running. Got a wet condenser right now, so we're gonna let it run for a minute and see if I find the need to put gauges on it. I'll do that, but we'll see. Let it run for a minute and kind of evaluate whether or not discharge gets hot, suction gets cold, and if not, then I'll put some service gauges on it. All right, my unit is pulling down. It's gonna take a little while. I've got some measurements right here. Let's see, my box temp is 41 degrees right now. I'd expect my condensing temp over ambient to be about 30 degrees, and we're running much lower than that. My outdoor air, so my building temperature is about 74 degrees. So if you add 30 to that, 84, 94, 104 is what my condensing temp should be, and we're not quite there. I'm still watching the box. Right now I've got the top section turned off and I'm just watching the bottom section. Currently my box temp is 40 degrees, so it is pulling down. So we're just going to monitor it and see what happens. You know, manufacturers on these units, they don't publish superheat and subcooling data, and you can't really use superheat because if you look back here, they're running the suction and the liquid together in the same insulation, so your superheat number is going to be skewed. And to get evaporator superheat, how are you going to get a probe in that tiny little coil back there? It's not really going to work out too well. You got to use some vital signs. So listen back here. You can hear that TXV hissing, kind of like it's getting vapor refrigerant to it, which is my thought, is that we're possibly undercharged. While I'm waiting, understanding the sequence of operation is really important on these ones too. So this coil down here has a temperature controller, but it's electronic. The sensors run in the coil and they actually come right over here to this guy right here. So this is the temp control. When I got here, it was turned as cold as it could go. Usually you want it set to the number 3, number 4-ish, about a third of the way on. The cold rail is controlled by that low pressure safety, but it acts as a low pressure safety and a temperature controller for the cold rail. So separate system on the top, single condensing unit runs the bottom system and the top. It uses that low pressure safety, but it sets the cut in and cut out to maintain basically 17 degrees air temp underneath those pans, which will maintain about 35-ish degree product temp inside the pans. So think of that. You can use that low pressure safety as a low loss safety. So if it runs out of gas, it'll shut it off, but it's set up to maintain temperature on the top too. Because the top runs colder than the bottom, they can do that. But they have to make sure that the cut-in pressure or temperature doesn't exceed the cut-in temperature of the bottom section, okay? I believe they cut in at 55, cut out at 30-ish PSI, I think, or something like that, if I remember right. And this is a 404A system. So right now I'm currently just running the top section. I'm just bringing it, letting it come down in temp. I'm pretty confident this thing's low on charge. From the factory, they tell you if you're going to check the refrigerant charge, they want you to mainly just look at the pressures. You can't ignore the vital signs, but mainly, like I said, they don't, you know, the vital signs aren't as critical on these. But you look at the pressures, 30 degree condensing temp over ambient-ish, that's kind of your metric. But you have to have the top section turned off. Because it's a static cold rail with no fan motor, it really throws the pressures off. So they basically give you operating pressures with just the bottom running. So, but I'm just letting the top run for a few minutes just to see how that functions, and then I'll turn the bottom back on. Actually, the bottom just needs to, it's down in temp and satisfied. So once it turns back on, I'll shut the whole unit down and we'll do a leak search and then possibly top off the charge. All right, so luckily this coil is pretty easy because it's open on the bottom. Let's see if we pick up any traces of a leak. Make sure it's not a false positive. Nope, it's back there. All right, I'm gonna pull the cover off the coils. It's kind of a pain in the butt, but looks like we got a leak back there. All right, let's get back in here and see what we got. I'm gonna go into the back of this coil right here. Yeah, it's in the back. There's like a section over there. Let's go back over here to the TXV and make sure it's not the TXV, because these have been known to leak too. Nope, doesn't look like it's the TXV. Smells like death in here. Yeah, so it's leaking inside this coil. Basically, you can see these return bends. It's on the other side. And there's no fixing that. It's so tiny in there, you just gotta change the coil. All right, I'm gonna put it together, top it off, and oh, also, this one is an older box, and it has this the sensing bulbs for the temp control. Has this little black connector. Those are notorious for shorting out. So part of my quote, they're going to get a new temperature controller and sensors too, because those little probes back there and that little connector, notorious. They don't want you using those anymore. So in order to charge it, we're going to turn the top section off. What we're going to do is, this is still closed. I'm going to open this and tighten this when it's leaking. Now what it was doing was I was purging the line of any air. Okay, so now this becomes my ball valve. I'm going to turn on my tank and then invert it, and then we'll start charging. All right, so now my tank is inverted because we always charge the blended refrigerants as a liquid, and we purged all the way up, so we're good to go. So on this particular unit, like I said, rule of thumb, if we're topping off the charge, is about 25 to 30 degrees above ambient. So currently right now, let's find my ambient temp. $76 degrees, so my condensing temp, 86, 96, 106-ish, somewhere between 100 and 106 degrees condensing temp over ambient is what we need to be, and we need to make sure that it's just the bottom section running. So, and we can just charge through the low side. It's just metering refrigerant in there. Just add a little bit at a time and go from there. I went ahead and put all the probes on the system just so I can kind of show what's going on. But so let's scroll over here. So look at my superheat. It's almost 30 degrees. It's okay. I mean, it's a good measurement. That's compressor superheat, okay? But understand that it's ran with a liquid line, so you know it's going to be a higher than normal number. If it wasn't ran with the liquid line, maybe we could use it because it's such a short run. But the next thing, let's go ahead and look at my and it's kind of scrolling as the expansion valve opens and closes. So look at my subcooling. Subcooling's kind of on par again, but it has a expansion valve, so that number is going to fluctuate as the expansion valve opens and closes. So notice the subcooling number moving. Okay, things are going to change there because this is a critically charged system. You know, it is a receiver and an expansion valve, but this is one of those things. I've never put a sight glass on one of these, but I'd be kind of curious to see how it operates with a sight glass. I'll have to do that one time. So yeah, this is what we're looking at. I'm going to leave it about here. I might put a little bit more, but it's definitely running good, just about down to temp. So I'm actually going to crack this door so that way it doesn't satisfy, because I want to keep watching it for a few minutes. It's interesting because measure quick, I'm just kind of looking. I usually don't use the troubleshooting feature on the refrigeration. But I believe they're using the subcooling because Measure Quick's actually saying that it looks like I'm overcharged. Finger may not be picking it up on the tablet. System may be overcharged. What I should do, out of curiosity, is diagnose a fully operating system and see how it runs. I think we just satisfied. Yeah, we just satisfied. So I'm going to turn the top section on. But yeah, I should put my probes and stuff on a fully operating system and kind of see how it operates. And use that, I guess, as a benchmark, kind of. All right, well, we're going to write this up as a new evaporator coil quote. Clean the condenser for now. It's operating, and before I leave, I'm just going to watch it turn back on. So we've got the low temperature. I'm using the minimum maximum feature on my 52.2, the Fluke, and we'll see where it turns back on at to verify that the temp control is actually working properly. Just another thought, too, is I use my Fluke 52 to do minimum and maximum temperatures to validate whether or not a temperature controller is turning on and off where it should be. Be kind of a cool feature to have that built into Measure Quick, to be able to use, you know, the return temp and then have a minimum and maximum, so you can just leave it in there and see the unit operate. I see this as being a really useful feature because you could almost just let it sit there for 20 minutes and see where the temps turn on and off. One of the difficult things about these reach-ins is they take a good 15 minutes when there's, you know, when they're not very busy. So this unit will take 15 minutes to cycle. It turns off and then, or maybe, you know, 10 minutes. But I mean, it takes a long time from when it turns off to come back up in temp. Partially because they do some staging of the evaporator fan motors within the temperature controller down in here. They use a Danfoss ERC, I think, temp control or something. But anyways, they stage the evaporative fan motors to try to reduce the cycle times and all sorts of stuff. So, but yeah, that'd be kind of a cool feature. So the temperature controller's working. That's what I love about this minimum maximum feature. So it came up to 40.7, turned on, and then now it's back down to 35 degrees. This is just on the bottom. So, all right, they're gonna be good for now. And like I said, we'll submit a quote. All right, sometimes, you know, the simplest little reach-ins, a little prep table, it's sometimes those things that give people the hardest time. There's not a lot of complex stuff going on inside that prep table, okay? Some things as I was editing the video, I realized I didn't cover. So the temperature controller for the bottom controls a solenoid valve, okay? And the solenoid valve opens and closes whenever the temperature controller says it's time to, obviously, okay? But I did say in the video that we have a single condensing unit running the top section and the bottom section, okay? The top section's temperature controller is controlled via the low loss and or pressure control, okay? So the top section runs whenever the bottom section is running by design, the way that the box works, okay? So whenever the bottom section is calling, the top section will cool. Now, in this particular unit, they do this for some customers and some they don't. This particular unit, they actually have a defrost clock for the top section. So this particular customer knows that the top section shuts off every night. We have it set up from midnight till 8 a.m. So they have to take the food out of the top section and put it in the bottom section because the top section gets turned off via the time clock, okay? Now, there's also a power switch for the rail too, or the top section. But it's very important to understand that the top section runs whenever the bottom does. Okay, that one throws people off completely, but that's the only way that it would work with the pressure control setup that they have to control temperature. Now, some of these boxes, they're spec'd by the customer. They actually have a temperature controller for the top section. And in that situation, the temp control controls a solenoid valve for the top, and then a temperature controller controls a solenoid valve for the bottom. Okay, so hopefully that makes sense. Now, with this one, you know, rules of thumb, I talked about charging these units. The manufacturers, they just tell you to charge them off of pressure, okay? So I have started to notice that it's right around 25 to 30 degrees is the condensing temp over ambient. Right in there. If you get it happy medium, you know, 28 degree condensing temp over ambient, you're going to find that the box works the best. If you weigh in the charge, it's going to be identical with that too, okay? So that's just kind of a rule of thumb. And then, you know, I see a lot of people on social media and different groups and stuff talking about charging prep tables. You know, you got to make sure that your subcooling's the right number. You got to make sure that your superheat's the right number. Either way, that's not necessarily the case because every one of these manufacturers, I always say this, they beat to the tune of their own drum. They do all kinds of weird stuff, okay? Such as running the suction line and the liquid line together. That's going to throw everything off, okay? That's going to make a higher superheat coming back to the compressor. And that applies to like on a capillary tube system. Some people say, oh yeah, you got to charge to the right superheat. Well, not if they're running the suction line and the liquid line together. You know, you got to be careful about that kind of stuff. So, you know, always want to pay attention. And then when they have hot gas condensate pans where they take the discharge gas running through a copper line through the drain pan, you know, that can throw off your subcooling numbers and everything too. So you got to pay attention to that stuff and be very, very wary. Always call the manufacturer and just ask them, hey, do you guys publish superheat numbers? Do you publish subcooling numbers? And they'll usually, everyone that I've called for the most part says, no, just charge it to these pressures, you know? And even some of the manufacturers, they're very vague. Like, yeah, you could probably do about, you know, and it's like, wow, I would expect them to say you do this, you know, not about, but yeah, be very careful about charging to just, you know, standard or rules of thumb. Even like me, I said, you know, I use a rule of thumb 25 to 30 degrees over ambient. You got to be careful about that. That's why I don't say it's exactly this condensing temp over ambient because I monitor everything. I look at how fast the box is coming down to temperature. I look at the current draw. You know, I look at a little bit of everything to kind of come up with the final, you know, proper operation. And that's just one of those things you have to learn about when you're working on these prep tables is there's not always an exact number to follow. And that kind of follows on a lot of air conditioning systems too. But anyways, we're getting off on a tangent here. Always want to understand the sequence of operation. It's truly going to help you. And then thinking about, you know, this box, like, you know, try to be as efficient as possible. right? So I went ahead and cleaned the condenser, and then, you know, I did a leak check on the evaporator. That happens sometimes even if I don't suspect a leak. Let's say that I have an iced up evaporator coil and I got to defrost it. Well, I got the cover off. I'll usually run my leak detector in there because it's like, why not? It's such a pain to get the cover off of those things. You always want to try to be as efficient as possible, especially on these prep tables, because they always have so many leaks, okay? And then also understanding what's practical. It's not practical to try to braze a leak on one of these coils. It certainly could be done, but I mean, how much is that going to cost the customer? And to be able to braze that evaporator, you're probably going to have to pull the whole thing out. Does that seem very practical to pull that whole thing out, to braze a leak, to put it back in to find out there's another leak? Like, nah, on something this small, you know, I just present the customer with the information. And even the manufacturer knows, you know, like for instance, if this box was under warranty, I'll go to them and I say, it's got a leaking evaporator coil. And they say, okay, well, we'll send you out a coil. And they've done this before where they send out just the evaporator coil. And I call them back and I say, I'm not going to put in just the evaporator coil. That's ridiculous. Send me the whole assembly. Like, I want the whole assembly. And most of the time, I'll get the whole assembly under warranty. That'll come with the fan motors, the drain pan, and everything. It just seems silly and doesn't seem smart financially, even for the manufacturer, to pay me to disassemble that evaporator coil, when if you just get the whole assembly, you only have 2 braze joints, a liquid and a suction line, and that's it. And it's on the back of the box. So always ask questions when you're dealing with these manufacturers. I said it recently on another video, or I think on a live stream or something like that. You know, certain manufacturers like True Manufacturing, you know, they have some best practices that a lot of people don't know about. You know, True Manufacturing, if you have a bad compressor, they'll send you a whole condensed unit if it's under warranty. You know, like instead of just the compressor, because they realize, you know, sometimes it's better just to change the whole thing. And you know, sometimes when you have really, really bad plugged up capillary tubes, I've gotten True to send me a whole condensed unit before because they know that the problem's in the oil. So always ask questions with these manufacturers. Don't be afraid to ask them questions and say, hey, you know what? I really think that you'd be better off doing this, and give them a logical reason. And majority of the time, they tend to listen when I give them a logical reason. Like, hey, you know, you guys are going to save some money if you just send me this whole thing. So just keep that in mind. I've been rambling again. Please, I said something in the video in the beginning. If you guys are interested, please check out my website, HVACRvideos.com. Lots of merch available on there. It definitely helps to support the channel. I really, really appreciate you guys. You know, it's amazing that we made it this far where, you know, in 3 years, the amount of subscribers and views that I get is so humbling, guys. It is just beyond belief. Sometimes I just wonder why you guys watch me or watch till the end to listen to me ramble. But I really, really appreciate you guys from the bottom of my heart. Thank you guys so very much for all the support. You guys are awesome. Remember, I do live streams on Monday evenings, 5 p.m. Pacific on YouTube on my channel, so long as I can get off work. And then also I do a YouTube show with my buddies on the HVAC Overtime channel. There'll be a link in the show notes of this video. The Overtime channel show is on Friday evenings about 6:05 p.m. We go live and just kind of talk about the week and everything. So definitely come check it out. Really, really appreciate you guys, and we will catch you on the next one.